1334, February 2nd, 2025. Right now marks 622 hours of progress on the Global Harvest simulation, and currently the system for rendering multiple quads simultaneously with them all sharing a single index buffer is working. This is really good that this is finally solved, as this will allow for multiple objects to be rendered simultaneously, but also their data does not have to be hard-coded as position. Now, for testing purposes here, the vertices are manually laid out, but an example of something that could be more robust would be a function that returns a vector of vertex data from just an inputted position and scale. Now, this is an example from another script that was aiming to do the same thing, but ultimately did not work because it was trying to do a lot more with sort of like applying a texture to each quad, which proved to be complicated when the logic for rendering multiple quads simultaneously wasn't even working correctly. Now, there was another project that managed to render multiple textures simultaneously, but it was sort of a cheat, and that can be displayed here. The reason it was sort of cheating is because the textures are actually hard-coded in the shaders. So yeah, so texture 1, texture 2, texture 3, so each of these in the input layout, it takes a texture index, and basically that texture index at the very end right here, so yeah, so 0 is the first one, and it has texture index 0, 1, 2, and that basically tells the shader which one to display. But this other recently working version with the quads doesn't have any of that for the shaders, and it will actually later on use a texture array, but for now, since they're just geometry, it returns a color for each one. And because samplers and samplers are only really needed when there's a texture incoming, and I said before, it was difficult enough to get it working to render multiple shapes simultaneously with each one sharing an index buffer. And yeah, so other than that, yeah, it actually uses, in order to display all of them, there's a vertex buffer. Each of these has its own vertex buffer, and there's a vector of vertex data, and for each of the data, it's pushed back into a two-dimensional collection, which is how this was solved. Maybe not the most optimal for each of them to have its own vertex data, but it was more flexible, presumably, than storing them all in one big vertex buffer, as one can easily index into the two-dimensional array and maybe manipulate the individual vertex data of one of the elements. And yeah, so here they all use the same indices, which was conceptually, that was the most difficult thing here, was probably just trying to figure out how to conceptually do this, as a lot of guides have just like one big indices and one big vertex buffer, or just a single triangle, and trying to render multiple of these proved difficult, but eventually it was understood. And set pipeline, there was originally a loop for binding them all, but that's being done from the draw call now. Yeah, so probably the most important part here is this. So in the draw call, of course, the clear color needs to be set, and the render target as well, with it being set to the DXGI mode, swap chain, flip effect discard, or something like that. Yeah, but if it was the normal legacy discard, then that wouldn't be needed. But anyway, so here's the important part. So it loops through the vector of vertex buffers and binds them all to the input assembly, and then it just draws, which is simple, just a simple draw index for each one. Now, a draw call for every single object isn't really the most optimal part, it's what's working for now, which is the important part for testing purposes, which is what all of this really is for, testing purposes. Just getting things to work. And so the intention for the next hour is to step away from the code for a bit and possibly learn some Audacity for learning how to manipulate sounds, and then later on today perhaps step back in the code and experiment with a sprite spawner. And yesterday the intention was to get the sprite spawner running in order to spawn multiple of these during the update call, or multiple textures. And so the idea is that there's maybe a grid or something, or maybe they just spawn from left to right, and as each second passes another texture spawns. And so yeah, that's the point. Going forward is to make this more modular and robust. So there are other projects for setting movement already, but up until this point there wasn't really a robust way to sort of render multiple things simultaneously, and now that there is, it can seem that things can actually start moving forward here, and placing multiple objects and possibly simulating a scene of sorts with multiple things interacting and having their own behavior.